our trip to Odell Park. Rock hounding! Woo! 4D, what are you doing here today?
Rock hounding!
Are we gonna have fun?
Yeah!
Are we gonna learn lots?
Yeah!
Awesome!
What do we have here now?
A boulder. It looks like a piece of history.
It looks like a piece of history?
It looks like a chair. A chair.
Yeah.
Lovely.
Well, this is what we call a boulder here, okay? We think about how they were formed, what type of rock it was. You think this one was formed by a volcano? You know, there are some that are formed by volcanoes. You're right about that.
Down by
Igneous
glaciers.
rocks.
And these glaciers were here, about 10,000 years ago. So how do we know there were glaciers here? Well, the Earth's crust really floats on top of what?
Water?
No?
Land?
Magma.
Magma.
Yeah, you know,
like
molten
lava.
rock, lava.
Just
Yeah. So what happens when you, as the weight got lifted up?
Yes. I have no TA. I have TA for like 20 minutes.
Sedimentary rocks, crust bedding, draining streams, and fossils.
It isn't even a complete sentence.
You have to talk about whoever wrote that.
Happy tone.
Those are just terms, I guess. What do you think they mean?
Guys, listen up, look here.
This is a fossil of tree bark, and we found this in a ditch that is just right next to the parking lot at Prospect Street Ball Diamonds. And the ditch has all kinds of fossils in them, and there's some leaves here that are stained, and we're going to head down a little bit further and we'll see some more. There's that tree bark.
It freezes, that's right. And what happens to water when it freezes? It expands. So you can see this rock here, it's starting to fall apart. And it cracks right in between where those little cracks in the rocks are, and it starts to fall apart. And we call this exfoliation. Just like your skin, you know, like when your skin gets dry and skin starts falling off, exactly the same thing happens with the rocks. It dries out first, it cracks, and you get water inside, freezes, and it falls apart. All right? So that's another kind of weathering. All right.
Cool. Very cool.
With that, tell you a little bit about erosion and deposition and the energy in the stream. And where Mike is, right there in the stream bed, the path is almost being eroded because when there's lots of water coming through here, the water bumps into this clump of trees with all these boulders, and it goes this way, and it bumps right into that side, and it erodes the bank on that side. But then what's happening is, behind this boulder here, and behind this, see all this sediment right here? Well, you dig into that.
Good example of erosion.
All really fine sand. And so that's because right here behind this boulder and behind these little trees, the energy goes down. There's less energy available. So all the parents,
The boys and girls eating on what they call the ledges. Looks much higher than what it is.
Waiting on 4 more boys.
So does anybody still have any questions?
I have a question about erosion. It's just that I don't know what the question is yet.
We're getting there.
Well, that's not a question. What's the question, Mr. Brian?
Yeah, that shouldn't be a question, right? Because we saw the layering, right? And it's the same kind of rocks we saw on the other side of the wall. Those were sediment.
This is the end of our trip. It's awesome. We started way over there in those trees and came all the ways around, down, in through here, and way down the creek trail. And came all the ways around back up through the ledge and the Nushuks back there. Awesome. Arriving at Creekside Trail. See the boys and girls and Mr. Grays. We go walking down. We're going down to the Creekside Trail now, where we're going to see some neat things as well as eat our lunch, which I think the boys and girls are looking forward to.
The vegetation holds the water and it lets it go slowly. Okay, so that's one of the big differences between this part of the landscape and that part of the landscape. And the other thing that we can see here is in these gray rocks, which are conglomerates of sandstones, there's fossils. You're standing right on a fossil there. In that, see over there too, you can see it over there too, guys. Yeah. Like right behind you, face the rocks.
Yeah,
look at the
yeah,
rocks.
look at this.
Guys. Okay, so
Claire.
what do you see? What do you see in the rocks? Trees. Moss, yeah. What do you see for like it moves. And as the glacier moves over these rocks, it smoothens out the rocks, and then the material that's between the rocks and the ice works like sandpaper, and you get all these scratches on the rock. And guess what? All the scratches go the same direction. When you go to the forestry complex, there's a big pond in front of the complex, and if you have time up there, but there's a big rock on one of the sides of the pond, and it has all these same kind of directions, and they're exactly the same. And how do we measure a direction on a rock like this? How can we do that? We can look at the sun, but we also have compasses, right? So we lay our compass on it, and then there's all sorts of markings on the rocks that tells us if the glacier either moved from that way to that way, or from that way to that way. And so in this case, the glacier moved that way, and it moved 144 degrees. So that's sort of in a southwesterly that there was glaciers. Now when you go to modern day glaciers, you can see that at the base of a glacier, there's all this gravel and sand and boulders and all those kind of things. And they work almost like sandpaper, you know? The sandpaper on... Yeah, I got some water too. I got a bigger bottle of it.
Oh.
You didn't get the jug?
Okay, yeah.
All right, I can use some of this. And what happens is, as the glacier moves over the landscape, it was coming from over there. Like if you go upriver, like you know where Woodstock is, the glacier was moving down this way. And how do we know that? Well, if you look on this outcrop here, and I'm going to use some of my drinking water here.
I'm going to use some of mine.
What do you see on the rocks?
Bumps. Like lines. Dirt.
Lines.
Lines,
here.
yeah.
Mud.
You move back, guys.
Right.
I'll move some over here.
Mud on it's dirt.
It's called a conglomerate.
But there could have been a river here thousands and thousands of years.
That's right. That's right. There could have been, and there were, right?
To me,
Do you know how long ago those rivers were here?
thousands of years.
About 325 million years ago. Can you imagine?
More than thousands.
So it would be quite well rounded.
Yeah.
Mm-hmm.
It's still quite angular, like you noted earlier.
C-O-N-G.
So do you guys know you've learned a little bit about erosion?
Yeah.
Okay, so what's happened to this rock? How has erosion affected this rock? Do you think that a lot of rain, 325 million years, we had a lot of rain? Go ahead.
I think that, like, right here, hit by rain or wind, and it made it crack a bit. Like
Sure.
right here.
Yeah.
Nice crack.
What happens when water gets in these cracks?
It splits them apart and makes them extend.
Into smaller rocks, right?
It reminds me of L-O-N.
What, pardon?
And I'll tell you that. I'll tell you the answer when we get to the next stop. But the soil, everybody step back a little bit so everybody can see. Okay. See this? This is a soil profile, what we call that, and it's all the different colors. And somebody stepped on it. That's all right. But you can also see them in the pit here. There's there's organic stuff on the top, and then when you go a little bit deeper, you find all this black, like gooey stuff, and we call it humus, and that's what's good for your soils. And if you garden, that's really good. That's what you want to have in your soil.
This year, all the dirt that's underneath us is the Earth's crust, and it goes down lower and lower.
It goes down lower and lower, and eventually you get to the rocks, right? Now, if you look at this, you see there's black stuff, and then you have a little bit of gray. I did that with this one here. I'll put it in there, and I'll go a little bit deeper afterwards. And then you get gray material, which is where all the minerals are leached out. And then you get this really brown stuff here, and that's the rich part of the soil. That's where all the minerals are really, the iron and aluminum and manganese. And then you go down and it gets lighter and lighter. And then at the bottom, it gets really, hard. Well, no, there's rocks inside of it. See, all these rocks came out of this pit. And you saw the big rock over there. What was that kind of rock?
Sedimentary.
Sedimentary rock. Yeah, it was conglomerate. And there's conglomerates in this soil. But at the bottom, feel this, how hard it is. And I'll show you. I'll dig a little bit deeper.
Can you pass it on, guys? Pass it on.
Get to that. When we look at rocks, we try to describe their properties. So if we were to describe this rock, what's some of the things that we might say about it?
It's coated in. Yeah, it looks like moss.
A bunch of moss on it. If we look at the rock itself,
It looks like ash.
yes.
It's soft.
What about these little things here?
It's made of other rocks.
There's other little rocks made of other rocks, right? Yeah. So yes, yeah. Well, this rock here, believe it or not, is probably about 325 million years old. That's old.
Cool.
That tree that it was
Way older than these trees. So we look at the properties. One property we might say, we try to decide whether it's sedimentary, igneous, or metamorphic. What did you guys know about sedimentary rocks?
Yep.
Yeah. How are sedimentary rocks formed?
They're formed by things. Sedimentary are formed by rocks swishing together.
That can happen with metamorphic rocks too, right?
Have you heard them as water rocks?
Water rocks, right?
Have you heard of water rocks? Sometimes teachers use that term. Yeah?
So if you were somewhere that looks, if you were in a riverbed nowadays and you're seeing where sand is collecting in the riverbed, you might see sand and you might see some pebbles, right? So that might be the environment that
Odell
this
Park is full of rocks and neat things to see. And today, my name is Tone. This is Pam. This is Serge. And this is Mike. And we're all geologists. And we're going to tell you things about soils and glaciers and different kind of rocks. And you can ask questions anytime. Just raise your hand and we'll try to answer your questions. In the beginning, we're going to go into the woods right here. And we're going to split you guys up into two classes because otherwise it just gets too busy around where we're trying to look at the rocks. And then we're going to go behind the ballpark and then we're going to go walk down the hill and make a little loop. All right? Where we're standing right here, it's actually a really interesting spot because on that side is the park. And on this side, there's ball fields, parking lots. And as we go down the hill, there's a big park with all sorts of different trees. This used to be an old farm. And how do we know it's an old farm? Well, it used to be an old farm. Well, there's all sorts of things that we see in the history of Fredericton. But also, if you look along the side of the parking lot here, this is what they call a hedgerow. And the hedgerow is full of rocks and boulders. And the farmer used to take the boulders out of the field